Student of 11th Science, today we discuss another type of projectile motion known as projectile given horizontal projection. First, we have to know what do you mean by horizontal projection. Whenever a body is thrown horizontally with a velocity from a point at certain height from the ground level, then the projectile is known as the horizontal projection. This is the diagram of horizontal projection. From the point O, which is at height h from the ground level, we throw an object horizontally with a velocity u. Regarding the horizontal projection, one thing you have to remember, at the point of throwing, there will be only horizontal velocity. There will be no vertical velocity. Okay. Now, regarding the horizontal projection, we have to determine number 1, the trajectory of the projectile, this one. Okay. Number 2, time of flight. Number 3, horizontal range. And number 4, the velocity of projectile at any instant. So first we derive the equation of the projectile by which the horizontal projection takes place. Now, to determine the equation of trajectory, we consider after time t, the projectile reached to the point P. So this is the point having the coordinate xy. Means after the time t, the horizontal distance covered by the projectile is x and the vertical distance covered by the projectile is y. And regarding the horizontal projection, always you remember the velocity along the horizontal direction is u. Why? Because along the horizontal direction there will be no force acting on the object. So that's why the horizontal distance covered by the body in time t is equal, distance equals speed into time. So distance is x, what is the speed? U, and time is t. So therefore t equal x by u, and this is our equation number 1. Now the vertical distance covered by the body in time t. What is the vertical distance? Y. So we have to derive the expression for y using the equation s equal ut plus half at square. Okay, so therefore s is y equal u is 0, because previously I say that at the point of throwing there will be no vertical component of the velocity. That's why in place of u here we put 0 plus half. For the downward motion, a is replaced by g and time is t. So therefore y equal half gt square. This is our equation number 2. Now from equation 1 we put the value of t in equation number 2. So therefore we get y equal half gx square by u square. And this equation is comparable with the parabolic equation y equal kx square. As the equation of projectile is comparable with the equation of parabola, therefore we can say that trajectory of the horizontal projection is parabolic in nature. Clear? Next, we have to determine the time of flight, which is denoted by capital T. What do you mean by the time of flight? See the diagram. The time taken by the projectile to go from O to A is known as the time of flight. Now, to calculate the time of flight, one thing you have to remember, the vertical displacement of the projectile is h during the time of flight. So therefore, to derive the equation for time of flight, we use the equation s equal ut plus half at square. S means h equal u is 0, because at the point of throwing the vertical velocity is 0, plus half a is replaced by g and t means time of flight, that is t square. So from here t equal root over 2h by g. This is the expression for time of flight. Next we have to determine horizontal range, which is denoted by r. What do you mean by horizontal range? The distance covered means the horizontal distance covered by the projectile during the time of flight is known as the horizontal range, which is in the figure Y to A. So therefore, previously we know the along horizontal direction the velocity is always u. So therefore, the horizontal range is equal horizontal velocity into time of flight. Horizontal velocity always u and the time of flight is t. So therefore, are equal u into what is the value of t? Put from here t equal root over 2h by g. So therefore, the horizontal range are equal u into root over 2h by g. And next we have to determine the velocity of projectile at any instant. We want to determine the velocity of the projectile at the instant of time t. At the instant of time, the projectile is at p. So, except the point O, if you consider any other point on the path of projectile, the projectile having two components of velocity. One is along horizontal directions denoted by Vx, another is along vertical direction denoted by Vy. Okay, clear? Now see the diagram very carefully. Here Vx and Vy are acting by making an angle of 90 degree. Yes, so therefore to determine the net velocity at the point P, we have to determine the resultant of Vx and Vy. So now first we have to determine Vx and Vy. So Vx what value? U. Why? Because we know along horizontal direction always the velocity is u, because there will be no force along the horizontal directions. And the Vy, to determine the value of Vy, we have to use the equation V equal u plus at. So in place of V, we write Vy initial vertically downward velocity 0 plus a means g and t means t. So therefore Vy equal gt. As Vx and Vy makes an angle of 90 degree, then the resultant velocity can be calculated by the formula V equal root over of Vx square plus Vy square. Now putting the value of Vx, u means u square plus Vy square means g square t square. So this is the magnitude of resultant velocity at the point P. As the velocity is a vector, we have to determine the direction of the velocity also, for which we construct a parallelogram over here, and according to the vector laws, the diagonal of this parallelogram is the resultant velocity. We consider this resultant velocity makes an angle beta with Vx. So therefore, according to vector rules, tan beta equal Vy by Vx. So therefore Vy is gt and Vx is u. So therefore beta equal tan inverse gt by u. So this is all about the calculation of horizontal projection. Student, all of you read very carefully. I provide lots of numericals on the projectile motion. Thank you.